Hi everyone, this video is for Pre-Calculus Unit 1, 1.1 functions. So do make sure that you read the textbook through first. If you've just recently had Math 140 or 99, then you're going to probably be very familiar with this section of the textbook. It kind of overlaps, as the same as that text, just for some of the sections. We will go quicker with it and more in depth. If you haven't recently had one of those courses, then let me know and I can give you some more details, or just go slower with it. You can pause the video, reflect. As you do your homework, there's also help videos in there. Again, make sure for the paper homework that you feel free to ask me questions. Even on quizzes, you can ask me questions. I'd rather you do that than try to hunt around and spend a lot of time with it. I can steer you in the right direction or make a video on demand. So if there's anything missing, just let me know. yfish@spscc.edu. So you are going to hear probably my family around here because we're all home, just like you all are. So one thing I want to make sure you do is print out, or you can just write out in a notebook or on plain paper, whatever works for you, the video companion sheet that you see here in the screen capture. That will be really helpful to use as a guide. But it's up to you. You don't have to print. What I do want you to do, though, is anything that I do for examples, you will write that down, copy that down. If you choose to do it on your own and then check the video after, that's fine too. Some things I say classwork, and I kind of put quotes around that. It's virtual classwork. But just if we were in a class and I'd show you some things, you would then want to try some, or I'd have you work in groups or something like that. So just trying to simulate that. The other thing to know is that you can submit photos if you have to, but it tends to, if it's a long document, it tends to take up a lot of space and you might miss a submission. It's just hard to track for both of us. You will have to double check that everything's in there. What will work great is if you do have a scanner and you can scan it to one document, that's great. As a PDF, I can annotate right on the PDFs. I can do that for pictures too, but it's just, they're all separate files. There are apps out there, and I'll probably try to get a video up for how to use that, but you can just take pictures and then convert it all to one PDF. Okay, so now let's get into the lesson here. 1.1 functions intro, things to know. We have variables can be related in many ways. A function is a relation in which every input is associated with exactly one output. The domain is the inputs. Usually we call that X, but be careful because it could be labeled as Y if it's years or something. Sometimes that happens in a word problem. Range is the set of all possible outputs. Usually that's the Y-axis, but I want you to try to think of that as a vertical axis instead of like a Y, because again, it could be labeled with whatever. I do want to give you just a little example here. Sometimes I think of a function as being an analogy, like if in a store, if I had a pen, I had to pick up a color here, pen, and it has a price tag of $1, and a marker has a price tag of, say, $2, should say. That could be a function. We could also have, let's go back here. Let's say we have a pencil, and that also costs $1. That would also be a function. That's okay. What we wouldn't have, I'll label this as function. What we wouldn't have as a function, it'd be a relation but not a function, would be if we had the pen costing $1 and it also costs $2. Okay, the same pen, right? It's the same exact one, has two different prices. That would be not function, not a function. So just kind of keep that in mind. Things that aren't functions graphically are like, would be something like that. Hyperbola. Also a circle. A circle would not work well. Okay. Okay, sorry about that. Sometimes my hand hits other things. So I moved my taskbar out of the way for you. But the zoom function will still show up occasionally. So we have the notation y equals f of x. And you should be very familiar with this. We don't multiply f times x. That's just a notation saying function of x. So whatever's inside here in the parentheses, that's the input. And y is the output that the function f associates with the input x. But again, it could be different letters. It could be y. We're calling, it could be x equals f of y, and then y would be the input. So just be careful of that. Dependence. If y is a function of x, then we can say y depends on x. Sometimes you've heard it called independent variable is the input, and the dependent variable is the output. If y equals f of x, then the average rate of change, we abbreviate that AROC or AROC, of f from x equals a to x equals b is notated as f of b minus f of a. So that's the change in your outputs. So change in y over your change in your inputs, change in x. So we just do use those for the generic. And that should look familiar to you as being similar to slope. We don't call it slope because it's an average, because it is not a linear function, it's a curve. So I've made a little graph here that you might want to jot down also. And this is a curve, but we're going to find the average rate of change between A and B. And we have the secant line here that we would be looking at. And that's what this formula gives us, the slope of that. So it's still the rise over the run. So this would be f of x, and this would be x. So you do need to get in the habit of labeling your axes because, again, like I said, they can vary. We use the generics a lot of the time, but it can vary. For example, in the class example, virtual class, we have b equals n of t. So b is just kind of like the generic saying that some function b, and we're going to be more specific now though with using the letters n and t, and we do need to label them. So I'm going to read through this, or you go ahead and read through this first if you want to try it, especially if you've just had 140. I think we might have done this same exact thing, so you can go through it really quickly, just brush up, or you can even put in your old notes, probably just the same. Okay, so here we have b equals n of t. That represents the number of birds in thousands, so be careful of that, make sure it's in thousands, migrating through Washington T years after 1990. So don't put the actual year in, make sure you subtract off. A, explain the meaning of n of 7 equals 9.2 using everyday language. So pause the video and think about that. Maybe start writing that as a point, an XY coordinate, or in this case, a TN coordinate, and figure out what that means. Okay, so in this case, we could write this as a point 7, 9.2. We could also think of this as 9.2 thousand, because remember it's in thousands. Okay, B is in thousands, which is the same as number of birds. And So the input, so I'm just writing down that note. The input is 7, and what that means is the number of years after 1990. So how I might write this is in 1997, 9,200 birds migrated through Washington. Now, sometimes I pause the video and finish writing because then I want to talk about something, and you can finish writing while I talk. But this 9.2K, we could write it like that. That would be okay to say, but we're talking about everyday language. So in pre-calc, we really want to start to do that more and more, where 140 or college algebra or intermediate algebra, whatever you took recently, we kind of introduce you to the idea of really interpreting and being more specific. And but now we're gonna really dive in more, and you will be graded on that kind of thing too. So make sure you do use just common language when you're asked everyday language. So if n of 9 equals 6.1, find the average rate of change of n from t equals 7 to t equals 9, and explain its meaning using everyday language. So we're going to use this formula from above. So we would have our AROC is going to be our, again, it's generic f of b minus f of a. Usually we do the second minus the first, but it doesn't really matter as long as you're consistent. And so for this particular problem, I have 1 point here is 9 and 6.1. Remember, that's in thousands. We can kind of just track that. But we're not going to write out all those zeros when we do it. We'll just write that in our final answer, and we should be good to go. So that gives me a pair. We also have the point from above. If you're wondering what that corresponding output is for the 7, it's right up here as the 9.2. So I also have that point to work with. So I have 7 and 9.2. So now I'm going to fill in. So my second one is f of b would be 6.1 minus my first value would be the 9.2. I'll divide it by the 9. That matches up with the 6.1. So I'm looking at this point here, but I want to take just the 9 minus the 7. And just go ahead and calculate that out, and we get negative 3.1 over 2. So we could say 3.1000 every 2 years, but in this case, since this is a decimal anyway, let's get it into a unit decrease. So a per year, because that makes more sense. It's typically how we would think of things in a yearly fashion. So I'm going to go ahead and calculate this out to be negative 1.55. I know you probably have learned to work in fractions or whatever a lot of the time and not round anything, but just for word problems and your final answers, if you do want to round, that's fine. It makes more sense a lot of times, or use mixed numbers. So you'll notice that difference as well. So then we just need to write it in a sentence. Why don't you go ahead and pause the video and try to do that on your own in everyday language, and I'll write it out, and then you can see how you match up. So the answer is there was a decrease of 1,550 birds migrating per year between 1997 and 1999. So that would be my answer. If you didn't have a sentence, you would be marked down for that. I'm really specific in the instructions, but at first, after a while, you should just know that. But for now, we'll kind of guide you through it. Just gonna get rid of this. So I want to point out a couple of things here. I wrote decrease instead of just a negative sign. Okay. I also made the 1.55K into regular, 4-digit number, standard form. I also made sure I wrote per year, and I wrote between the years 1997 and 1999 because that's the only place in this curve possibly that occurs. So we do need to be careful to mark those properly and put the range, or the actually it would be the domain for our average rate of change. So I am going to try to keep these videos shorter, so you'll probably have a few per lesson. This one's getting kind of long, and it's a good place to stop here, but so that people can upload things or download and then get rid of them later if they need to, depending on what you have for internet service. I'll do that, but remember, each lesson is probably like one class length all compiled, so expect to have maybe an hour's worth of lectures, but within that there are classwork problems to try, and you can always do that on your own and then check back against the video as well. So this is the end of part 1 for 1.1, and I will get the next video up shortly, and have a great day.